Our next speaker, our last speaker of the day, is Brent Mauti from CH2M Hill. He's going to speak with you about the Skyway Wastewater Treatment Plant in Burlington, Ontario, Canada. So thank you very much.
Thank you. So my name is Brent Mauti. I'm the global BIM leader for CH2M Hill within our water market. So a little about this plant. It's within the region of Halton in Ontario. It's to the west of Toronto. And you can see it's right at the bottom tip of the overall region in the city of Burlington. Now, what's unique about this plant is it's actually underneath the Burlington Skyway. So it's actually prime real estate with lake to the top and bottom, and you'll see that in an image in a moment. So the plant itself, its upgrade was triggered by a requirement to, first of all, raise the megaliter per day capacity up to 140 from 118 to address population growth, as shown on the previous slide. But also there was a huge initiative to actually help to clean up Hamilton Harbour. So if you're not familiar with Lake Ontario, it's been known to be somewhat polluted, and it's both because of industry and waste and improper treatment during the mid-20th century. So to address that, a lot of the plants have been upgraded throughout the province, and this upgrade is to help in that overall initiative. So the harbour as that area of concern, the focus of that has been the introduction of a tertiary treatment to include to update the phosphorus removal of the waste before the water is discharged into Lake Ontario. And that phosphorus removal is part of an overall plan governed by the Department of Energy within the provincial government in order to help to reduce the outfalls into the lake and to help clean it up. This project was triple funded, so there was funding both from the federal and provincial governments of Federal of Canada, Provincial of Ontario, leaving just 1/3 of the funding to be privately funded through the client. So that was a huge win from their perspective. The other thing, the contracts, it's interesting that they wanted to push the project along on an accelerated schedule, and we'll look at the contracts in a moment, but they wanted to try to leverage and harness the benefits of what a design build project would have, and also what they've learned from alliance projects down in Australia, even though the contract terms were just simple design bid build within Ontario. So they were hoping to just leverage mostly collaboration, quick decision making, and more risk sharing versus mitigation. And so far it's been quite successful just from a conceptual standpoint without it actually being fully mandated through contractual obligations. So this is the existing site, just an overall picture. The changes on the site are centered around various areas, and you can see it's quite spread out. One of the biggest challenges was actually first understanding what's actually there, right? Modeling this site, interpreting the P&IDs. The stack of historical data over the last 70 years was just unbelievable. So we dealt with that in an interesting manner, I think. Contractually, they broke the project up into 4 contracts. We are right now at the completion of contract 2 and 3. Everything's on schedule. The site remediation is about to start after Christmas. So the unique part is contract 3, the requirement for the laboratory building. And there's some interesting things we had to do with the tools in order to help facilitate the overall design and construction of that building. And then the rest of all the treatment processes were done under contract 2, including starting with the PFD, the flow diagrams, through the P&IDs, into the model, etc. Some interesting challenges as they were excavating, they actually found some interesting archaeological ruins. So there were some grave sites of the, I can't remember the tribe, but it was Aboriginal peoples of Ontario. It might have been the Iroquois, I can't remember. So they had to deal with those and address what they were going to do and how to address them. And they were just, it was unique with what they found. Some arrowheads, horseshoes, etc., from the passageway through this region. It was this tight piece of land to try to circumvent the entire Hamilton Harbour. So it was pretty interesting what they found. The plant had to stay operational. And that's probably one of the biggest challenges on sites like this. We couldn't turn this thing off and stop producing 110 megaliters a day. That was just completely not an option. So the staging of the construction was critical, the flow of information to actually help facilitate that. The contaminated soil was addressed with, there was just a decontamination routine during excavation so that the soil can then be reused when it was during the site remediation contract which is about to occur. So just from a BIM perspective, as with most projects in Ontario, the client required a DWG deliverable. When we looked at that, we said that we could achieve that, but we offered to put up the I models as a turnover, and there were also stakeholder agencies that were Autodesk focused, and they only knew how to run Navisworks. So we had to have Navigator plus Navisworks plus MicroStation plus AutoCAD, all that play throughout the duration. We are going to turn over our Projectwise repository, so we're going to do a complete export of the project and deliver that to the client so that it will have maintained references and relationships between files for them to then import into their document repository, which is not Projectwise. We had to customize OpenPlan P&ID for specific tagging schemas to meet their legacy requirements of their operational plant. And then we did a heavy customization on EcoSim, which I'll talk about in a bit, but it was focused on the laboratory data requirements to help them estimate and fund the operation and laboratory building, which for the project they referred to as Skylab, so Skyway Operations and Laboratory Building. And a lot of those customizations actually led to our overall global deployment of the project. So the focus, it was a multidiscipline project for every single facility. In this model on the top right, everything that's a yellow Pantone, that's all the existing modeling. So the first initiative was to take the historical data, plug it into Projectwise. Now, by that I mean paper drawings and some really, really bad ones. So we scanned everything. We categorized it all. We plugged it into Projectwise. When I show our folder structure, there's a folder called historical data. And underneath there, it was broken up by main treatment facilities, so whether it's primary, secondary, solids, etc., broken up by year, and we just put everything in there. From all that historical data, we now had to point to either reference PDFs into MicroStation or to actually just have them on one screen, model on another screen, and get the base existing model. Now, it's not modeled to perfect detail. It's obviously enough detail so that we can take everything new and plug it into the existing or connect to the existing to ensure the interfaces were of adequate design. Everything's multidiscipline, so CH2M Hill, one of the benefits we have is everybody's contained within our entity while we're doing design. So the work sharing for us, interdiscipline coordination, has to happen by nature, and then the work sharing is distributed across our offices. And that building on the bottom, that's the operation and maintenance building. Because that's a people-focused building, there was a lot of interest from our stakeholders with respect to how this is going to look, how they can access it. It's the visitor center. It's the port or the gate into the rest of the plant, and they wanted that to be somewhat of a showpiece for people to come and visit. So this is the list of Bentley tools that were used, and it's quite a robust list, and what I like about it is because of the project, we started design, or I guess existing modeling, I want to say 2011, I believe it was. A lot of stuff happened to these tools over the last 3 years. So this project, I'll just point out a couple things here. It was in Canada, our first use of the mobile apps, and I'll talk about that after. But the mobile app evolved, so Projectwise Mobile, they had the iPads. They said, this is awesome, we can connect to the data source, but do I always have to go down this tree and actually expand it all? Field Supervisor came out, a year ago, and all of a sudden we said, look, you save a view, access your site. They just thought this was great. Bentley Building became EcoSim, and it was timed for this project so perfectly for the operations and maintenance building, and we'll talk about that. It was our pilot use of EcoSim in Canada, or actually globally in our metric offices, so that we already did it once in the States. I was then able to take what we learned there and build and expand our legacy metric data set for global deployment and use of EcoSim. It was also, again, our second pilot of BRCM, first one metric. So it allowed us to take the Raceway tool, learn what we did on our first one, and expand it, update, augment the data set, and deploy it globally as well. So one of the huge benefits for us with Bentley is the synergistic nature of all the tools. So Projectwise is our hub, and we do that for global distribution and deployment, which we'll talk about in a bit. The civil solution was Inroads, and the building solution was initially Bentley Building, then EcoSim. The beauty is they talk. So unlike some of the competitors Bentley has, there is no such thing as being unable to collaborate. So we're virtually designing on top of each other. They both feed MicroStation, and from that, everything is synergistic, and from MicroStation, we can get out to AutoCAD as needed. Now, the plant solution, it's always intriguing. This project was occurring during our piloting or onboard configurations of OpenPlant. So we have OpenPlant P&ID active on the project, yet plant space was still in use as we were working through conversion of plant space specs into OpenPlant. So we started with the P&IDs because P&IDs are the foundation of these projects, and as we move forward, it's the OpenPlant environment that's going. But those P&IDs had a loose connection to the plant space environment, so we were still able to consistency check, but not in an automated fashion as we would today. But the fact that we have the SQL database backbone to all of this helped to spear off some, or spawn some intriguing ways to actually connect to that information. OpenPlant P&ID also housed our PFDs, and those PFDs were part of the deliverables that we had to turn over to the client as well to form part of their maintenance and management systems. BRCM was the other tool, and again, it had that same synergistic link to all the models. So you can see the whole purpose of this diagram is to show that overall connectivity and why we select the tools we selected because of the purpose of their use, and why the Bentley solution, for us, actually, when we talk about that efficiency, what difference does it make? That is a huge difference right there. One hub, multiple ports for data authorship, one form of deliverable. Even though deliverable was AutoCAD, MicroStation's our hub. We have overall enterprise CAD standards, full interoperability with Autodesk environment. Things go from MicroStation to AutoCAD. Clients happy. We're fully interoperable, building civil plant-based information. We then had Navisworks and Navigator as our review tools, and they were both used depending who the stakeholders were or the consumers of that information. So I always keep mentioning is building civil plant, they have to happen in Unity, they're synergistic, they talk to each other, and we have that wrapped around our overall enterprise platform for software and hardware, all integrated, all globally deployed. I keep stressing globally deployed because that's the most important thing to actually achieve these projects in the tight schedules that we have. Because we have that, I don't have to worry about that. I have to worry about what's on the right. Owners' repositories, other repositories. How do I get the stuff from our environment to their environment? Now, this project, when I talk about the BIM goals, operation and asset management, it wasn't identified as a specific goal, but by nature of doing a treatment plant, we always have PFD, P&ID turnovers. And there's always an element of inclusion of that content into a computerized maintenance and management system. Now, because this was an operational and existing plant, we didn't have the requirement to develop that as an output or as a final solution, but we did have a requirement to turn over specifically those PFDs in order to feed and or update the CMMS based on the new treatment process that was being developed and deployed throughout the course and schedule of this project. When we build our BIM execution plans, we have a standardized approach based on the Penn State plan, augmented regionally to make it fit for purpose. So this here, you can see the green highlighted portions. Those are the BIM goals that were heavily utilized within this project. And as I said, the operations asset management, it was really just a feeder to an already existing system. Drawings and schedules, I won't even talk about that because that's just, it's what we do. We have a model, we get that. Visualization, this was a critical piece, and not only for design, but also for the stakeholders throughout the duration of the project. So one thing the client said to us, had an idea, can we make a calendar? Can I have something to distribute at a stakeholder meeting to let them understand what we're actually doing on this site? So we said, what an awesome idea. Got into Navigator, did our stills. We had our pubs guy pull a calendar. So obviously we did this in the end of 2011. It was a November meeting. This was the takeaway. I hung this on the wall in my house, and my family just laughed at me, but it's all good. So, you know, it was the BIM calendar. We portrayed it inside. Look at what we did. It's a great way to just have a takeaway on the project. Client loved it. Stakeholders just got a pretty good understanding. The model review portion was an interesting one, as here there was heavy focus on actually bringing the model from design into construction and utilizing that model specifically, and not just saying, yeah, we have a model, here's our drawings, things happen for 2 years, and now all of a sudden we have to make an as-built. So we actually had a heavy focus on the concept of it became, currently we call it the paperless job site, but back then it was, we want to actually go as paperless as possible with respect to our drawings and continue the utilization of this model. So they took the iPads or they took the laptops, went to site, did constant verification against the models themselves, and always came back with these types of images. How close are we? Is it making sense? Is it as we designed? If it's not, what's been changing? And we'll get to that in a moment. Clash detection, we set up automated routines, usually through Navigator, but sometimes through EcoSim as well, because it maintained the full EcoSim information. We generate reports, bring them up in design review meetings, not so much during construction, but it was more so during that design process, assigned it to the various individuals, track them and determine which ones have been resolved or not, and those that were not, obviously the question is why. Now, being the BIM manager role, I'm always pressing these buttons. I'm waving it in the design manager's face, waving it in the engineer's faces, and you know, and it makes a difference because eventually they will address these changes or these interferences. So it's a successful approach when it's used diligently throughout the course of a project. Now, cost estimation, this is an awesome one for us. We have a close connection with our estimators, and they've told us what they want to see and how they want to see it. They've been all over concrete for over a decade now, telling us specifically what they want, where they want net area, where they need gross area, where they want net volume. And the EcoSim deployment was so timely because the concept, everything has data no matter what, versus in the previous versions, a lot of it had data, and we had to make sure that everything did. So I describe now the BIM tools. It's harder to model unintelligently than it is to model intelligently, and I think that's awesome now, but it actually raises some interesting questions. So laboratory equipment. In that Skylabs building, we had to quantify the lab equipment. So I go into EcoSim and I say, place lab equipment. No, there's nothing there. So we stepped back and said, how do we do this? And we actually built some routines to actually update the data groups, modify them, allow us to place the components that we wanted to track, worked with our estimators to see what are the high-ticket items, built placement tools for the lab equipment, sent the architectural team off and running, generated our reports thereafter. We actually had some success with the analysis portion of this. So taking aside process flow, because for me that's just nature of what happens on plant, we actually took that Skylabs building, plugged it into eQuest. Now, when I say plugged it in, it was not perfect. It wasn't push a button, away it goes. It was coordinated, and I thought that's fair. So I didn't push a button in a way. But we had energy modelers in one of our offices. We had other BIM modelers in another one. They were coordinating that output to and from the energy analysis tool, ensuring that the data being plugged in was representative. So the energy consumption was based on the equipment and the items either pulled off the P&ID or pulled off of the architectural models, based on the electrical outputs that were assigned to the components, categorized and cataloged, and pushed to the energy tool to pull in from a spreadsheet. So quickly on collaboration, this was our Projectwise folder structure, and notice at the top there, as-built drawings. So that was where we had absolutely everything, and historical data. everything that came from that site over the 60 years is now in Projectwise and will be turned back over. The breakup of all of these facilities, every facility was modeled, every facility went through the procedures we're describing, specifications for each contract, etc. Notice RFI, RFQ as well. So this was part of the concept where we said we're going to push this into construction. I'm just going to be mindful of time here. Our Projectwise deployment, Skyway was a feeder to help develop our overall deployment of Projectwise. So just in a nutshell, we have corporate data center, local caching servers across all of our offices. Therefore, anybody touching the office, I think in the previous slide, I can't remember how many offices I said, everything was local, everything was synchronized. That's the power of Projectwise. Through that gateway, we were able to access mobile on site. And that's the critical piece for the RFIs. To deal with the resources, this was a critical thing as well. So I'm not always plugged into any one of my offices. I'm going to take that information away. I'm going to go onto site. I'm going to go lock myself wherever down in a pit doing who knows what in the middle of a treatment plant under the Skyway bridge. I don't have a network. So we needed to ensure that we can take that information and run. So we developed what we call Projectwise Resource Manager, or PRM. And this is in essence the idea. Access the collaboration system or the common data environment, check out my file, pull down all the resources I need, unplug and walk away. Do my work, plug back in, send it all back up. The synchronization process is a critical piece for us, and this is what we've spent years developing, and Skyway was one of our pilot projects to achieve this. We have compressed resource files in Projectwise that we delta file to the computer. That's it. So thousands upon thousands of files are compressed in those four for this project. Once they're on my C drive, they get deployed, and then all of our workspace configurations point to the C drive. So whether I'm inside CH, outside CH, anywhere in our offices, any external entity, client, stakeholder, or on site, everything's on my C drive, everything's accessible, and everything's fast too. The other beauty are those XMLs. So part of the issue with Bentley's plant tools is it has to write to my registry. So in order to do that, we launch from Projectwise. We tell Projectwise right to the registry. Once it's written, everything's good. The plant tools work. With that technology, we've extended that to all of our Autodesk-based applications, so we can write AutoCAD profile, Civil 3D profile, Plant 3D, registry settings into Revit. Anything that can be controlled from a registry gets controlled by a Projectwise double-click, set, consistent. Everybody's happy across the project, no matter where you are in the globe, whether you're in CH or outside. We also said, okay, there's a wealth of information not visible to everybody. So not everybody can run a SQL query. I even get confused. I go into the database. I don't know what I'm doing sometimes. So we put a wrapper around Projectwise. We said, what if we want to just see who's on the project? A quick list of users, maybe what's on my drawing list. So we have a query tool that are either based on our some saved search criteria or just other items that the general user will not be able to see. Web-based application, double-click, show me a report. Within the confines of a Projectwise rich project, we can yield these reports. Great when we have a lot of externals and a lot of people collaborating on site. We extended this now for any PNID-based tool, any SQL-based tool. So OpenPlan PNID and BRCM, we now have a reporting tool that we've globally deployed. You can access the SQL database without having to actually go into the tool itself. PNIDs are done somewhere else. SQL database is queried by anybody across the globe. And lastly, RFIs and RFQs. So this example here, this is just the blower bill, one of the blower supports, and needed a change. So the change, this is the RFQ, do all of that stuff. And I said, okay, great. This is the drawing. Now, I'm telling you, I know that's not impressive, and everybody knows that's not impressive. But the beauty is it was accessed by site, modeled, that was the existing model, and this is the modified model. All done on site through Projectwise. So as I said, you grab the content when you're in the trailer connected through Wi-Fi. I go into the building, watch what they're doing, design a solution based on the current as constructed conditions at that moment. update the model, send it back to Projectwise, engineers or architects look at it, verify, validate, produce the output, RFQ's done, and we feed that back to the client. Quick and efficient and fully connected via the Projectwise environment. We could never do that in traditional methods, and to meet the schedule, as I showed at the beginning, this concept here of having fully connected, true and valid information and extending it throughout this construction period is just something that we're gravitating to heavily now. So because of concepts like this, we have an overall global initiative called the paperless job site. So not just RFIs and RFQs, but all your change orders, design notices, everything that should be associated to construction, we're plugging into Projectwise now for overall global access and connectivity no matter where you are. No more SharePoints, PCMs, other tools all feeding into the same thing. So just a quick summary here. We've got validated data throughout the entire coordination process, both through design and construction, resulting in an as-constructed model upon completion of the project. Standards and workflows are consistent across all parties authoring content and updating content. Building civil and plant-based synergy is so critical, and it's a passion for myself as well to be able to say that we do have solutions that allow all these parties to talk. The construction lifecycle we just talked about. Distributable BIM is a huge one too. Everybody can access our project and everybody can feed it. So it allows us to harness the power of CH2M Hill to meet specific or strained construction schedules. And virtualization, saving the cost of understanding what we're doing and why we're doing it. Questions?